something new today, but also take some of this experience and improve for the future. All right, so what we're going to be talking about today is how to build web components with StencilJS. So for a quick high-level overview, StencilJS is a compiler for web components that was built by Ionic, who is famous for their Ionic framework. Now, StencilJS's goals are basically to make it easy to build web components by taking a lot of inspiration from some of the modern frameworks that we use today, and to fix some of the problems that actually plague vanilla web components. However, before we actually jump into what StencilJS is and what it does for us, it's a good idea for us to quickly refresh ourselves over what web components are. So according to webcomponents.org, web components are a set of web platform APIs that allow you to create new custom, reusable, and encapsulated HTML tags to use in web pages and web apps. Now, web components are based off of 4 major specifications. You have custom elements, you have the shadow DOM, you have ES modules, and then, of course, you have the HTML template element. Now, generally speaking, when you hear people talk about web components, it's more than likely that they're referring to the custom element spec specifically. And the custom element spec was created to standardize how we build these HTML elements specifically in a way that modern browsers themselves can understand. So after mentioning custom elements, it's worthwhile talking about what they are and more specifically what types of custom elements there are. So according to the spec, there are 2 types of custom elements. The first is known as an autonomous custom element, which is an element that is defined entirely by the author. That is to say, these elements do not extend any of the functionality of existing HTML elements. It is entirely up to the author to decide how do users interact with this, what is its behavior, what is it going to do, how do screen readers deal with it, so they're completely standalone.
Justin, I'm going to interrupt real quick. Can we turn the lights off for this? Because the rest of his syntax highlighting is going to be...
Oh, geez, yeah. Thank you, Taylor. Well, maybe if let's see here. In the meantime, well, what does that do? Oh, that's worse. Well, I could go ahead and continue a little bit here. Yep. Okay. Cool. All right, so we've covered the autonomous custom element. Now, the second type of custom element is what is known as the customized built-in element. Now, these types of custom elements, awesome, thank you. These types of custom elements are made specifically so that you can extend the functionality of an existing HTML element. However, this part of the custom elements spec is still very much a work in progress and is not at all supported by WebKit, unfortunately. So as you see up here on my slide, for your consumers, they would, for an autonomous custom element, they would use it in their HTML by using the name that you've given to your custom element. But for a customized built-in, they would actually use the actual element that your custom element is extending and then basically upgrade it or progressively enhance it by using the is attribute and then providing the name of your element there. So generally speaking, when people refer to custom elements today, they're likely talking about autonomous custom elements. So now that we know we have an overview of what web components are, and more specifically that we're typically talking about custom elements, why would you want to create web components in the first place? So when you're building a component library, the technology that you build with them has advantages and disadvantages. So before choosing the technology you're going to use, it's important to answer a couple of questions that I've laid out here. So first, you're going to want to know who's going to be using your component library. How many people, teams, or projects are going to be consuming this library? And then once you know that, it's important to know, well, what frameworks is this team or teams using? Are they using React? Are they using Angular? Is it a mix? Can teams choose whatever framework that they want? Now, if you're lucky, maybe all of your consumers are going to be using the same front-end framework. So let's say everyone's using React. It might make sense for you to go ahead and just build your component library using React. However, that then brings us to the third question. When might they actually switch frameworks? As we all know today, we all know how fast front-end web development changes. There's so many new frameworks that seem to be coming out every single year. And with these new frameworks, it's important to know just how long these consuming teams might be sticking with that particular framework. So if you go ahead and build all of your components in Angular or React, and they decide to switch front-end frameworks, let's say 2 months, 6 months, a year down the line, was it really worth the effort to do all that work when now you might have to throw all of that away? So ultimately, if you're building your library as web components, you're choosing the browser spec and the native API that you get in the browser over the features of any singular framework. And what that's going to do for you is that it's going to guarantee that your components you're building will function inside of the browser without relying on any sort of external library or framework to render them. Okay, so we covered why you might want to build, why you might actually want to build web components, but what are some of the drawbacks? Well, one of the largest drawbacks of web components is that they need JavaScript to render. Naturally, what this means is that your site could be completely unusable when JavaScript breaks or times out, fails, or let's say your client or one of your users just doesn't have JavaScript enabled. So now they might not be able to use your site. And because it requires JavaScript in order to hydrate your components, it also means that the initial HTML that's getting sent up from your server might contain these elements that have nothing in them. So if you're building web components that are containing content that you want web crawlers to be able to look at for SEO, well, suddenly you lose out on that. Another pitfall has to do with the performance and bundle size. So with vanilla web components, each new component that you build will increase your overall bundle size. It will add yet one more component that you're going to have to register with a browser. And it's just more code that's needed to render your page. So without coming up with your own custom bundling or cool registration strategy, what you're going to do with vanilla web components is you have to register them all up front on the browser before your page loads, and you might even be registering components on that your initial page might not even use. Another drawback of web components is that you might get some duplicated shared resources, since all of these components kind of run in isolation of one another. So each web component that you build might have these external resources, and then it means that for every instance of your component, you might have repeated code, ultimately increasing your bundle size even further. Now, while there is a standard on how to build vanilla web components, there's really no standard on how you go about testing them. So besides coming up with your own strategy, ultimately, if you're going to be building vanilla web components, you're going to be spending some time going onto Google and looking at articles to figure out, hey, how do I test these? What's the accepted way to test these? So ultimately, it's all up to you to figure that out on your own. And then finally, the web component spec is very new, and it's not evenly supported across all modern and legacy browsers. Because the spec does continue to change, not all browsers are going to support those changes at the same time. So if your goal is to build a web component library, it suddenly becomes your responsibility to make sure, well, am I bundling the right polyfills? What browsers am I supporting? Do I have the right polyfills? Are they getting applied? And even if you do have that down, well, you're now including polyfills in your bundle. That's increasing the amount of code, that's increasing the chance for bugs, and it could worsen performance. So with all that being said, I might have just completely undermined any desire for you to check out web components for yourselves, right? Well, with every problem in web development today, we all know that there's going to be those that are going to try to solve these problems in their own way. And so one library that attempts to solve some of the problems that I've laid out here is StencilJS. So to reiterate, StencilJS is a compiler for web components built by the team at Ionic. And Ionic originally created Stencil because there was a lot of asks to be able to use their Ionic framework and Ionic framework components between multiple frameworks, because they were originally just an Angular house. So what they've done is that they built Stencil internally. They had a lot of success, and since then they've made it open source and available to everyone. Now you might be curious about the compiler part of that description. So what Stencil is going to do is it's going to have you build these components in their syntax, and those components are going to be put through a build process that will turn these components into standards-compliant vanilla web components in the long run. So Stencil provides a number of features to take advantage from when you're actually building your web components. The first one is JSX. So anybody who's familiar with using React, this will be very familiar to you. So they use JSX templating syntax to define all of your component markup, and we'll take a look at this when we get into the demo in a little bit. The next feature that they offer when you're building your components is lifecycle methods. Yet again, another similarity to React. So you have lifecycle methods such as component will load, component will update, which are available for you to manage your component behavior. However, I would advise against caution. For anyone who is familiar with React, you want to be careful when you're using these to manage your state of your component or managing how it renders, because some of the same pitfalls that we've seen there, like unnecessary re-renders or buggy behavior, could occur if you are not careful. Another feature that Stencil provides is lazy loading. So to help with the whole performance and bundle size issue of web components, all components that you build in StencilJS are lazy loaded by default. That is what Stencil is going to do in its build process is it's going to create multiple individual JS chunks per component that will be asynchronously fetched by the client when the browser needs them. So what this is going to do is that you're not suddenly bundling all of your components and including it at the very top. The browser is only ever going to get what it needs when it needs it. So if that first page only contains a couple of components in your library, then it's only going to fetch what it needs to render only those components. You're going to get faster load times, and of course, I'll be covering this in a little bit more detail in the upcoming demo. Image there is just a little bit of a teaser to show the network graph of what the browser is doing to go out and fetch those JS chunks. Another feature is server-side rendering. So Stencil allows you to customize its build output. And basically, the way it does this is that its build process can generate multiple different output targets. And one of those targets that you can define is a hydration application. So basically, what you could do is you could take this hydration app and put it inside of the server, inside of a server middleware that would be serving up your HTML. And it's for anyone who's familiar with React DOM render to string. You take your HTML, you pass it to the method provided by Stencil, and it will go ahead and hydrate all of your Stencil components and then send that up in its initial render. So that helps us not only with that initial paint, but as well with SEO. As far as testing goes, Stencil provides a lot of tools to help you properly test your components. So they provide two different helpers. There's the new spec page and the new end-to-end page. The spec page is basically something that you use to render your component inside of JS DOM. So if you want to test small pieces of your component or just like individual pieces of logic, it's a very fast and easy way to do that. Alternatively, you could use what they call end-to-end pages. So when you want to test your component's full behavior between inputs, different interaction states, when I pass this in, or when I interact with it in this way, what is it going to do? You use the end-to-end testing helpers for that. So your end-to-end test will verify your component's behavior in a real browser by using Puppeteer. So the output that you get and what you're asserting on is the actual output of the Chromium browser and not like the JS DOM. That's something that we use internally, and I really like it. So for end-to-end testing, Stencil also has a visual diffing solution. So in this API, basically what you could do is, as you're building out your component library and you're going from version to version, it's worthwhile to see, well, how have my styles changed? What is happening here, right? Like, did I break anything? So what Stencil will allow you to do is via this little code snippet here, and if you want to learn more and you pull down my slides, you can click on each of these links and it'll tell you a little bit more. But what it'll do is it'll generate a before. Oh, let me go over here. So it'll generate what your components did look like in your last build, what they look like in this current build, and then, of course, what the diff is at that point. So it could be very handy when you want to ensure that you're not breaking anything visually. Now, one major feature that Stencil provides is framework bindings. So web components, again, were created to standardize how custom elements are handled by browsers. And while this does help with framework compatibility, it's not necessarily going to ensure that when you use these web components inside of a framework, that they're actually going to work. So real quick, I want to direct your attention to a site that I like to look at called Custom Elements Everywhere. And basically what this site is for is to just kind of see, well, how are web components being handled by some of the more popular frameworks today? And as we scroll through this, we could see, yeah, they're actually, for most of these front-end frameworks, they are handled pretty well. You could kind of use them right out of the box. However, there are, of course, some exceptions to that rule. React being one of them. For example, React, whenever you're going to be trying to render a native element inside of your render method, and you want to pass some data to a property, well, it's not going to do that. It's going to just try to pass everything as stringified attributes. So if you have a component that with an object, or let's say a function you're trying to pass to it, it just simply cannot do that. So during our demo, we're going to take a look and see how those framework bindings actually work. Now, when you're working on your component library, it is very important that you have a way to quickly see your changes as you're making them. So Stencil provides its own built-in dev server that we'll be able to see during the demo. Here's just their CLI and how you would go about starting it up. And then lastly, Stencil also has the ability to generate documentation for all of your components. So if you're using proper JS.comments above your code, your component classes, your props, your state variables, you can then ask Stencil's build process to generate either a README file that lives alongside your component code that will contain tables for all of the custom events it emits, your props, and everything, or you could generate a JSON file that explains what your components are, basically metadata for your components, that you can then include in your own doc site to hydrate your doc site with your documentation. All right, so that does it mostly for the slides, so I'm going to go ahead and jump into the demo. Before I do, are there any questions? All righty, so give me 1 second. I'm going to set this to mirror. Make sure that looks good up there. Set this to this. All right, fantastic. Is that readable for everyone, or do you want me to maybe increase the size a little bit? Up, got it. How is that? Perfect. All right. So before I actually jump into the code here, one thing I do want to share with everyone very quickly is how simple it is to actually get started with Stencil. So I'm just going to very quickly bring up their Getting Started docs here. So if you want to go ahead and just start building a component library with Stencil, it's very easy. You just call npm init stencil. And when you do that, it's going to ask you a couple of questions, and it's going to start off by having you select one of these 3 options. Now, I'm not really going to go over the first 2, but what I will say is that, yes, technically, you could build your entire app with StencilJS, effectively making your app one giant web component, however you feel about that. But ultimately, what Stencil's going to be for is to just build a collection of web components. So you're going to select the 3rd one, and then it'll ask, what's the name of your component library, and a couple of other questions from there. So once you've run that, your project is going to look a little bit like what you see on the left-hand side here. It'll generate a source directory for you, a place to put all of your components. It'll generate an index.html that you'll use for your dev server, and then this stencil config TypeScript file that we will take a look at in a little bit. So for the sake of simplicity, let's just go ahead and take a look at what it's like to build a component in Stencil. So unfortunately, I'm not going to be doing any live coding here. If I did, then there's a good chance for bugs, so I'm just going to be walking through this one step at a time. So you're going to start off by defining your class. So in this case, we say export class toggle button. Pretty simple. After that, we're going to go ahead and import a couple of things up here from Stencil core. And what we're going to import is the component decorator, a prop decorator, a state decorator, and then just a required H from Stencil core. Since we're using JSX, this is kind of required for their own build process. So you might be wondering, if you're not super familiar with TypeScript or other languages that use decorators, just what a decorator is. So a decorator provides a way to add annotations and metaprogramming syntax for your class declarations and members of that class. So what that, basically they are a means to modify the classes and members that ultimately follow them, and Stencil's going to use these decorators at build time to properly understand what your code is and how to transform it into a vanilla web component. So what we're going to do is that we're going to decorate our toggle button with this component decorator. Before I continue, I should mention exactly what type of component we're building. All we're going to do is create a simple button that's going to track whether or not it's on or off, and when the user clicks it, it's going to change state. Very straightforward, very simple. So again, we're going to decorate our class with this component decorator, and this is going to take an object. And that object is going to take a couple of parameters. The first one is the tag. So the tag is basically the author's way of saying, well, what is the name of my component? When they go to use this in their HTML, what is it called? In this case, I'm calling it JN toggle button. Now, typically in the web component community, it's a pretty accepted practice to prefix all of your components with maybe the name of your company. In this case, I just decided to use my initials. Second, we want to provide it a style URL. Now you'll see I have this commented out. I'll go over that a little bit later, but the basic thing here is that the style URL is going to take a string, and that string is going to be a path to the CSS that describes how to style the component. It basically is telling Stencil that, okay, here's all my component logic, here's the styles, and here's how you're going to basically bundle this up into the JS chunk that you're going to have lazy load. Okay, so that's the basics for defining our component. Now what about the API for the component? So we're going to define a couple of props. The first one is we want to allow our consumers to say whether or not on first render the button will be in a pressed state or not a pressed state. And the way we do that is we define this default pressed member variable for our class. We're giving it a type of Boolean that'll default to false, and we decorate that with the prop decorator. So what the prop decorator is going to do when it sees this is basically make it so that your web component will be able, or your consumers will be able to set this prop either via a reference to the element, where you would use camel case default pressed, or your consumers can set it as an attribute. But as we might know, you don't really have camel-cased attributes in pure HTML. So what Stencil does is that it creates a hyphenated version or a dash case version of that prop to be used inside of HTML. So default pressed becomes default hyphen pressed in your HTML. We're also defining two more props, basically allowing the user to say what should the internals, what should the text inside the button say when I have it pressed or when it's not pressed. Pretty straightforward there. And then, of course, we define our internal state. In this case, as I mentioned, we're only keeping track of whether or not the button is pressed. So we do that by defining our pressed var. It is a Boolean by default. It is a Boolean, and by default, we are setting it to whatever the user has passed into default pressed. And if they don't pass anything, then, of course, it's going to inherit false. And we decorate that with the state decorator. So what this is going to do is that Stencil is going to recognize this to say, OK, this is a state var. So whenever this changes, I'm going to want to re-render the component. So again, if you're coming from React, it's a very similar concept if you're maintaining state on your component. And of course, as the user provides new values for props, the component is going to re-render. Yeah?
Does Stencil use TypeScript by default?
By default, yes. In fact, I don't know if you can get away from TypeScript with Stencil. OK, so we've defined our API. We've defined the internal state. So what is the markup for our button? So pretty straightforward. In your Stencil component class, you need to provide a render method, and that's going to return some JSX. Again, very similar to React. In our case, we have our button. We provide the classes that need to be on the button to inform how to style it. In this particular case, you'll notice I'm just going to be styling it like Bootstrap. For the purposes of accessibility, we want to keep track of when the button is pressed. So if a screen reader looks at this, it knows what to do and what to say. So we take our pressed state var and we say toString, since, again, we're assigning this to a attribute. And then we define our onClick listener. Again, very similar to React here. We pass it a callback. And all this is going to do is when we click on it, press is just going to invert itself from false to true, from true to false. And then finally, for the text inside of the button, we just take a look at our state var, and depending on its state, we're either going to render what is provided to pressed text, so if true, pressed text, and if false, we're going to render the unpressed text. So pretty straightforward, right? Well, why don't we go ahead and take a look and see what this actually looks like when running. So what I'm going to go ahead and do here is start up the dev server, and it's very simple to do. If you're using the CLI, all you have to do, the CLI to generate your project, you could just do npm run start. So this is going to run this through its dev process here, open up a new window, and there's our button. Though you might be asking, OK, well, how did that get up there? Like, where do I actually go to put my components? So in the source directory, I mentioned we have this index.html that is used by the dev server. And if we jump into here, this is all generated by Stencil for you. So the only thing you really need to worry about is what you're putting in the body. You'll see it includes the scripts that it needs to hydrate all of your components right up here. So as you can see in here, I have my toggle button. And as I go over here, yep, that's exactly how we've set it up. And what I can do to test out our API is I could say, OK, default pressed. Oh, excuse me, pressed. And if I do that, what it's going to do, oh, thanks, VS Code, there we go. So that's going to go ahead and so the dev server does have hot module reloading. So as I change the index.html or I change the internals of the component, it'll automatically refresh for you. So here I set default pressed, and it's set to on. Of course, if I get rid of it, then it'll refresh, and it'll be set to off. OK, cool. So our component is working. Now this is the part where I'd like to talk about, well, how is the component actually being hydrated? What is kind of happening behind the scenes? So this is where we get into the lazy loading of our components. So what I'm going to do here, assuming you can see, yeah, it looks big enough, is I'm going to disable my cache on my browser, and I'm going to go ahead and refresh the page. And let's keep an eye on what happens inside of my network graph here. Yes, I'm going into my DevTools for that. Oh, bump it? Oh, yeah, sure. Is that good? Cool. Maybe one or two more. Cool. All right, so as we can see here, we can see some of the JS that the server is going ahead and fetching. So it's pulling down the main bundle, pulling down these two, but then we'll see this particular file it's pulling down right here. This is the JS chunk that I'm talking about. And again, this is the JS chunk that defines not only the logic for the component, but as well as the styles for the component. So what it's lazy loading is both of those together. So we can kind of see how this works and how we can take advantage of this if I go into my index.html and comment this out. So our toggle button's not there. When I refresh it, it's not fetching it. But what I can do is if I go and I split my console here, and hopefully, let me just bring this up a little bit, bring this down a little bit here. So let's say I did something like this, const button equals document.create element. And this is going to be our JN toggle button. Cool. And then we'll just say document.body.append child. So what we're going to go ahead and do here is append our web component to the body on the fly. And when I do this, it appears and it dynamically fetches that JS chunk for you. So again, your consumers aren't downloading all of the JavaScript that they need all up front when they want to actually use these components. Now, the way Stencil does this in the background is they effectively initially register what's known as a proxy component. And what that proxy component does is it just says, oh, the browser goes to hydrate it, it sees it, and the proxy component says, cool, I'm hydrated. But I can't finish hydrating until I have this JS chunk. So then the browser will dynamically fetch that down, and then the component will hydrate. That JS chunk can be cached, so as your users visit your website in the future, they're not always making that request. They can pull that from the cache. So that's pretty cool. It helps with performance, and it ensures that we're not running too much code or pulling down too much code. But how could we take advantage of this maybe a little bit further? Well, if I go back to the code here, I have this style URLs that I mentioned earlier. So let's go ahead and bring that in for a moment. So what is the style URL? What is style URLs doing? So what you can do is you can pass to style URLs, let's say, a list of strings to different CSS style sheets that Stencil will then kind of splice together and bundle up into your chunk, or your JS chunk. Or you could provide it some key value pairs. So what the key value pairs are is you are defining a mode or a theme to be paired with a particular style sheet, is what you're doing. So then you might, OK, cool. So that's awesome. But how do I have my users go back, choose what theme that they want? Well, that's entirely up to you. And Stencil kind of gives you a very nice way to define what that API is going to look like. So once we have this, what we could do is jump into our Stencil config.js that I mentioned earlier. And this config is basically describing to Stencil what different output targets do you want? What is the name of my project? And it also gives you the ability to provide a global script. This global script is going to run before Stencil does anything else, before it registers any of your components. So what I have is a global TS file here that's pretty straightforward. And what it's going to do is, well, first we bring in something from Stencil Core called setMode. And what setMode is going to do is it's going to take a callback. That callback is going to take the element. So basically, what this means is that you could define the API on each individual element. So if people want, oh, I want this theme for this button here and this theme for this button there, But generally, if you're building a component library and you're doing theming, you don't want them to mix and match themes. So here's what I'm doing. I'm defining my accepted list of themes, and then I'm looking at the root document element, or in this case, it's going to be the main HTML tag, and I'm looking for an attribute that I'm calling JNTheme. I'm going to grab that and store it into theme, and if it's not there, I'm going to default it to Bootstrap. Then I'm going to check that that theme is one of my approved themes, and if it is, use that. Otherwise, return Bootstrap. So this is what that looks like. I'm going to go into my index.html, and here I have JNTheme being set. So let me set this back to Bootstrap. I'll get into what Suite is in just a moment. So if I go into here and I refresh, oh, I need to go and bring this here. OK, same as before. It looks like a Bootstrap button. But oh, notice now that the JS chunk has JNToggle button Bootstrap. That's interesting. Well, let's go up and try to change this to our other theme. Kudos to Taylor for informing me about these particular styles. I was like, what do I want to show off? Do I want to show off like Bootstrap and Material and Lightning? And he's like, I got you. So we have what we call the Sweet CSS button theme. If I set that at the root of my document and go back, here we are. And you'll notice, yeah, isn't it great? It's fantastic. What better way can I show like the differences between two different button styles, right? But the main thing I want to show off here is that, well, down here, it's pulling in a different JS chunk. So what Stencil is going to do is that if you want theming for your components, it will create multiple chunks for your components based on the theme that you want. So what that means is like, well, instead of having to include all of the CSS for all of the possible themes for all of my buttons up front, you can bundle it this way, so you'll only ever bring down the CSS that you need for the theme that the user has chose. So I think that's pretty cool. Cool, so we've gone over how to create a very simple component. We've gone over how you could use theming and lazy loading. Let's go ahead and maybe step it up a little bit of a notch. So I've gone ahead and I've created a to-do list component. We're not going to go too much into the details on how I built this component, but at a high level, what this component is it accepts a prop that is a list of to-do items. So a name, a description, and whether or not that item is complete. It's going to render those items in a list, and it's also going to provide a form of which to add new items. So the way that the consumer is going to use this is that they are maintaining the to-do list themselves and listening for changes, and then passing that back into the to-do list. The to-do list is not maintaining its own state. So just to kind of reiterate a couple of small things here, I have my items prop, but I also have something new here, my event, my custom events that the component is going to emit. So I have add item, complete item, and incomplete item that I decorate with the event decorator, and I give them the type of event emitter. So if anyone here is, might not be familiar with custom events on the DOM, basically what they are, they're very similar to native events, but they have a detail attribute in there that you can use to emit all sorts of different data on. So in this case, we could provide a generic to describe what that data is. Honestly, I should have actually done to-do item here, but I didn't, so it should be fine. And then, of course, the way that we use these in our code is if I go down to this part, so here we have an unordered list, we're iterating through our items, and we're rendering those items out. And next to those items is going to be the toggle button that we just built, where I'm setting default pressed, which is going to be pressed if that item is already done. Text to mark whether or not the item is complete, and then we have our onClick listener that says, well, if it's done and I click this, we're going to emit one custom event or another custom event. So let's take a look and see what this looks like when it's getting rendered out. So I'm going to show to-do list here. I'm going to show this script here. So again, it's up to the consumer to maintain what this list is. So here I am just doing it in pure vanilla JavaScript. I set up my to-do items. I get a reference to my component. I set the items prop, and then I set up my event listeners. Again, won't go over it in detail, but if you pull down, I'll have all of this up on GitHub so you can take a look at it yourself. So when I go into here, I should be able to see. Let me refresh this real quick. Oh, I have, oh, that's interesting. All right, you know what? For the sake of, let me set this back to Bootstrap. I have some conflicting styles going on there. OK, cool. So here's my to-do list, and okay, here's my items, and as I mark them as complete, they're emitting custom events, I'm reacting to it, I'm updating my list, and I'm passing that back in. I could say item 3, test, add that in, passing that back in, and it works. Cool, awesome. Well, we have a very simple component, and we have maybe a slightly more complex component, but how are these actually going to work in some of these popular frameworks that we like to use, like such as Angular and React? Well, for that, I actually have an Angular project and a React project set up to demonstrate that. For the sake of time, I think I'm just going to go ahead and show React for now. Angular, we've already seen on custom elements everywhere that it handles it fine, no extra things you need to do. Feel free to take a look at that on your own volition when you pull down the project. I'll have a link to it at the very end. So let's jump into our React demo here. So inside of React, the first thing that we're going to want to do is define our custom elements. So what Stencil's going to do is in the bundle that you're going to be publishing up to NPM, what users could do is they can reach in and grab this define custom elements method from a loader that is bundled with everything. And all they have to do is at the very root of their application is call define custom elements and then pass the window object. That's it. That's all they have to do. Then they could start using your web components right away. So I will jump into the app.tsx here. Here's our toggle button. OK, cool. Let's go ahead, jump over to React. Just say npm run start. And we're going to see how this behaves. So give this a second. I'm going to have to actually build my project here. So I'm back in my Stencil project. Maybe say npm run build. I'm using a symbolic linking at the moment since I don't actually have my stuff pushed up to npm, so npm link. So we've done that. We'll need to go back into React, go into here. I need to do one quick thing here. I'll go over this in just a moment, but do that, do that. OK. So what we're doing at the root of our Angular application is we're going to start just by rendering our toggle button. Oh, cool, and there it is, and it's working. And by default, if I refresh the page, it's defaulting to on. Great, awesome. Let's try using our to-do list now. OK, so how would I go about using this? Well, I have my to-do list, and OK, well, I know that I have to listen for some custom events, but React has its own synthetic event system. How is it going to know to listen to those? OK, well, I guess what I could do is I could use refs. I could get a ref to the web component and then say element.add event listener that way, but then I have to make sure that, on each re-render, is it going to recreate those event listeners? Am I going to do it correctly? It makes for a very bad experience for anyone using React to consume your components. But OK, let's not worry about our custom events. Let's just see if we can pass items to it, right? Let's just see how it's going to render. Oh, wait, where's all of my items? OK, I have my list of items here. This is a bit, by the way. Not actually. So I have all of my items here, and I'm passing it, but why aren't they there? Well, what's going on? We can inspect element, go into the DOM here, try to find our component, and OK, items is object. Oh, right. We can't actually pass them this way. So what are we going to do for our React consumers then? Well, this is where framework bindings come in. So what I can do inside of my stencil config, so I'll go down into there real quick here, is I can define different output targets. Now, again, by default, what Stencil's going to do is it has a regular distributable that you can publish. And then, of course, it has something else that it uses here for the dev server, or if you were to build like an entire site. But we also have this React output target that we import from Stencil/React output target. So we pass this to our list of output targets. And this takes an object where we define what is our component core package that we're going to use to build these bindings. And by bindings, really what I'm saying here is we're going to be building, or it's going to be outputting actual React components that are effectively wrapping and setting everything up for our web components. So after we've named our core package, we then have to say, well, where are we going to be building these components? Where are they going to go? So in my case, I'm going up into my React demo project, going to the components folder and saying build these in components.ts. So I did already run a build, so we'll take a look and see what that file looks like going into here, components.ts, and we could see this file has been generated where it has actual pure React components that it has created. So why don't we go ahead and try using these instead? Awesome. So, okay, forget this. We already know that this doesn't work. So here I have my generated React component. Let's make sure I'm importing that from the right place. And here, so you would basically use this component just like you would any other React component at this point. So I could say items equals the stat.state.items. Well, we did that before. We'll see if it works again. But Stencil knows that I've defined these custom events. I've defined add item, complete item, and incomplete item. So it's like, okay, you defined these events. So I'm going to go ahead and build the React component and create props so that people can actually listen to those events and react to them. And that's exactly what we're doing here. So without further ado, if I jump back into my React project, we see, I'm just going to refresh this here to be sure. Cool. We see that the component is working perfectly fine now. And I can so I can react to items getting complete or incomplete. Just as before, I could create item 3 and react to the add item event that's getting bubbled up. So test, and it's working perfectly fine. So Stencil gives you a lot of different tools to try to solve a lot of the problems that web components have today. SSR, working within multiple frameworks. We've been using it at Kroger for like the past year and a half, and it's worked out great for us. So with that, I don't really have any segue into the ending, but are there any questions? Oh yeah, let me actually bring up my slide. That's a good idea. Where do I have that? Here we are. Cool. Yes?
So if you're publishing like a public package with Stencil components in it, would
Yes.
you just rebuild the React component and publish that alongside it, or like?
So yes, that is what we would do. So basically, there's many different ways you can kind of go about it, because ultimately you're going to be publishing your Stencil component library to NPM, but then you will have your separate publishable React component library that depends on your Stencil library. Because again, what these bindings are doing is that they're wrapping those web components inside of a React component, so those web components are still required. Did that answer your question?
Yeah, so is there some, I guess, kind of like how there's like a scoped like types? I don't know, is there a way that you can say like, oh, I see this is a stencil, is there a corresponding React component package to that?
Yes. So are you asking like, actually getting proper type defs in there and actually seeing like this is available and here's the props on it, or?
I guess like a naming convention where you see like, oh, this is a stencil component. I wonder if it has a corresponding React package or module.
I think the way that Stencil tries to handle it is that you'll see it has that JN prefix on there. Now, you could totally go in here and come up with whatever kind of name you want for these components at the end of the day. I could change the name here and then use it by that name elsewhere if I want to. If you're asking if there's any standard way that you would deal with that, there really isn't a standard. It's kind of up to you how you want to do it. At Kroger, we have a React component library and our Stencil component library. So typically, if I were to say, write something once in Stencil and get it to work in React, I would probably just get rid of the prefix and have consumers use it just as they're used to using any other React component library. Cool. Any other questions? So.
Is there a functional syntax for?
Yes. So inside of your Stencil components, you can define functional components. However, those won't be compiled to web components. So what you would use functional components for inside of Stencil is for reusable components, right? I'm using this component over and over and over and over, but it's not necessarily something I'm going to publish, right? So that's where that would come in. Yep. Any other questions?
Justin, I noticed you mentioned a form when you were talking about adding things to your list.
Yes.
And just in my experience, when I got started with React, man, there was no semantic HTML consideration whatsoever. It was slap divs everywhere. Is Stencil, does that get you closer to the HTML spec, do you feel?
Yes, I will say that, so I've originally come from mostly a React background, and in working with Stencil for the past year and a half, it's kind of, at least this is just me talking, me personally, it's nice to kind of get away from some of the niceties that some of the frameworks kind of provide for you and actually think about, well, how is this component going to behave with the native browser APIs? I have to think about things a little bit closer to the metal. So in that sense, yes. Yeah. So.
Sorry.
Yeah.
If someone had published a Stencil, I guess, component, is there a way for you to like consume it in React without them actually publishing a component? Like,
You mean publishing it to NPM?
well, so they have a Stencil component, and then is there any way in your build as like a consumer of their Stencil component to say like, I want to try and use this in React even though they haven't like, rather than them making the choice to say like, I want this piece to be able to be consumed in React.
Oh.
Like, kind of the consumer themselves can say like, can I pull the Stencil into my
Absolutely, they definitely can. So the main reason why you would ever want to use the React bindings is for your components that have complex APIs, right? If you have, let's just say, a component that renders an icon, and you choose the icon via a string prop that says, I want the plus icon, the minus icon, you don't really need bindings for that. React is going to know how to actually wire up those attributes. It doesn't need the bindings to properly render it because you're not passing complex data, you're not listening to events or anything like that. So they could use those as is. That being said, if you do have complex components, then it would be up to your consumer to write those wrappers themselves, either using hooks or using refs on the element to say, okay, I'll manually wire up these event listeners. Yep.
Or you would need to import that library into your project as a consumer and rebuild, right?
Yes.
Your component.
Yeah, so if you, yeah.
Make sure that you'd be able to use the bindings or create your own.
Yeah, you could just, clone their repo, include the bindings, and then hit build, and there you go. You have your bound components.
So I have a couple questions.
Yeah.
Like, so on the server-side rendered part, is there like when it makes a build, does it do a cache busting string on it?
Yes, it does. It will generate its own. So for each build that you do, it'll actually look at the component and see if it has changed, and if it has, it will generate a whole new JS chunk with a whole new string there.
And is there a recommended strategy for people who are writing the enclosing app so that maybe the initial render of that actually prefetches some of them? Or does it always involve that second round trip? I mean, I know it matters less with with newer network stuff. But.
So I have two separate answers for that. The first one is there really isn't any standard way to go ahead and prefetch all of that, lest you in the background are like appending the elements to the page and not actually showing them to get it to go out and get them. So there's that, kind of a hacky solution though, if you're just going to subsequently add them. The second one is in the latest version of Stencil, which isn't fully released yet, one of the output targets that you can define is, okay, I don't want lazy loading. Just give me the vanilla web components that get generated all in one script, and I'll include that myself. So if you wanted to, you could just have that as your output, have that included, so you're not making multiple round trips at that point, depending on how your page is set up.
I just know from like a web performance standpoint, while splitting everything out does tend to decrease the amount of network traffic you use. One of the main reasons that you decrease network traffic is to improve perceived page speed.
Yeah.
So if you have a couple round trips in there, you're kind of impacting that.
That is true. So
same data plan, but
yeah, at that point it really depends on. It's all up to you to kind of like balance your app with what components you're building, right? I mean, something as simple as like a button or an icon that's pretty quick to fetch once it's all gzipped and minified. We've seen, at least for a lot of our consumers, things get hydrated super fast. But yeah, it is a bit of a balancing act.
And the cache busting is pretty nice, I think.
Yes. So. Yep. Cool. Any other questions? Awesome. Thanks, everyone. Awesome.